Hi, everyone. My name is Tim, and I am one of the engineers on the Azure Spring Apps team. Today, I want to share with you how Spring, along with Azure Spring Apps Enterprise, unlocks the power of AI in your applications. I will show you how to add AI features and capabilities to your existing Spring app, and how Azure Spring Apps Enterprise enables you to deploy these applications at scale and production ready with ease. And so today I'm going to start with a short, hopefully inspirational demo to show you how we might add some AI capabilities into an existing Spring app. What we're going to do is we're going to add a generative AI feature into our e-commerce app that enables customers to interact with our store in a more intuitive and hopefully revenue generating way. And then after the demo, we will look at the technology underneath the hood that powers the demo. We will look at the Spring AI library, and we will look at Azure Spring Apps Enterprise. So let's get started with the demo. Imagine that we are developers and we work for an online sports store selling bikes and bike accessories. Fitness Store is an application written in multiple languages. Spring Cloud Gateway routes incoming requests to the front-end application or the back-end APIs, which are written in Spring, Python, and .NET. All the components in this system are deployed to Azure Spring Apps. The application uses a Postgres database to store state data and Azure Key Vault to store secrets. Azure Active Directory is used to perform single sign-on for authenticating customers accessing the Fitness Store application. Let's imagine that e-bikes are gaining popularity. They have cool features, but they are expensive. People have lots of questions about them. So we decide that we want to provide a smart AI assistant to help answer questions that customers have directly on the web application. The goal is to help customers decide faster and place more orders for these e-bikes. We work with our design team on these ideas for the AI assistant, and now we need to make it happen. So let's open our IDE. We know that our front-end web application is written in JavaScript, so we will need to make changes there. But there's a new part we need to add to the application as well. We need to build a new Spring Boot REST API that processes messages from the web app and sends them to an AI service. We are not sure how to design or code this API, so we'll head over to the Tanzu Application Accelerator extension in VS Code. It has ready-to-use application architecture made by experts at our company. So let's see if there is anything useful there. Yes, it looks like someone put an AI accelerator, so let's give that a shot. We'll enter the project name, click the AI section, and we see different AI patterns. We'll pick question and answering because that's the kind of feature we want to add to our application. And since our company uses Azure, Azure OpenAI is the best choice. Click Next to create the project. I checked the accelerator's README instructions, and it looks like I'll need to use Retrieval Augmented Generation, or the RAG pattern. That's great. There's a diagram to help me understand how RAG works, with links to learn more about AI and RAG. And so let's see what the accelerator generated. Let's look at the POM file. Here we see that the POM file includes the Spring AI Azure OpenAI Spring Boot Starter that will auto-configure the Java client for interacting with OpenAI ChatGPT models hosted on Azure. Spring AI is a new experimental Spring project. It provides portable abstractions for working with large language models in a Spring idiomatic way. You can use it to quickly implement common patterns for AI interactions. It's new, and your feedback will be helpful to shape the product, especially since the AI landscape is changing rapidly. Let's look at the code next. The LLM client interface is used to send prompts to a large language model to get a response. To learn more about Spring AI, check out the Spring AI project. To recap, we added a chat box to the web app using JavaScript. The application sends messages to the API we built with Spring Boot. This API talks to the Azure OpenAI service by using the Spring AI module to interact with the large language model. Deploying our applications on Azure Spring Apps is simple. We don't need a Docker file or Kubernetes YAML file. We just upload our code or jar, and the Tanzu build service builds container images for us, and Azure Spring Apps Enterprise manages the rest of the deployment. The best part, it's easy and straightforward. In less than a day, we can be proficient with Azure Spring Apps Enterprise. It's a game changer for Spring developers deploying apps on Azure. The new app, Assist Server, is now up and running alongside other services that are part of the application. This information is all visible in application details. And once the app is running, we can configure Spring Cloud Gateway to route traffic to the application using JSON and the Azure CLI. And we can see the configured routes here. Okay, so now the apps are live and our customers are asking questions. These questions go to the Azure OpenAI service and answers come back with product links. Customers can even ask follow-up questions and get more replies. So I'm new to e-bikes and I'm looking for a new high-performance bike. Great. Well, how fast can it go? And how far can it travel on a single charge? You can see the answers come back. How long does it take to charge the bike? And can I ride it in the rain? That's a really important question because I live in the Seattle area and it rains frequently. Do I need a license to ride an electric bike? And what is a good maintenance plan for these types of bikes? Let's debug the application and see what's going on. I can see the code as it's running on Azure Spring Apps Enterprise. I can step over line by line using VS Code on my MacBook Pro. So let's ask a question and see how this works. What accessories can I consider for the bike? Now you see I've hit a breakpoint running on Azure Spring Apps Enterprise. I can step over line by line here and see what's going on with VS Code. I can see the question sent from the web app and the response from the Azure OpenAI service. Here is a list of accessories, so let's pick an accessory. Hopefully our customer is convinced and adds the accessory to the cart, a win for our company. Spring unlocks the power of new and emerging AI platforms, and it unlocks the power of Azure. It lets you focus on building your application without worrying about infrastructure. The result, more items in the cart, better sales conversion, and more revenue. I hope the demo was inspiring and gave you some ideas on how to add generative AI features in your existing Spring applications. Let's take a look at the technology that we used for this demo. First of all, Spring AI is a new Spring library, and it is available at spring.io. Spring AI is a Spring idiomatic way to unlock the power of AI, especially generative AI, in your applications. Let's look in more detail at the different abstractions and capabilities that Spring AI provides. If you are not familiar with some of the terminology here, don't worry, it's okay. With Spring AI, you can get started quickly, and then you can dive into these different generative AI features as your needs expand. And so for this discussion, I will cover some of these features at a high level to show you the power of Spring AI. First, Spring AI supports all major model providers from companies such as OpenAI, from Microsoft, Amazon, Google, and Hugging Face. And so no matter where your company has decided to deploy your AI models, Spring AI will work with your model provider of choice. Secondly, Spring AI supports all major vector database providers such as Azure Vector Search, Chroma, Milvus, and so on and so forth. And so you can find and pick the vector database that is best for your scenario. Third, Spring AI is portable across AI providers for chat and embeddings. Both synchronous and streaming API options are supported. Dropping down to access model-specific features is also supported by Spring AI. Again, these are features that you don't need to use out of the gate, but you can use it as your needs demand. Finally, Spring AI supports chat and text-to-image out of the box, and there are more model supports on the way. In short, Spring AI provides a high-level, simple-to-use integration of generative AI in your applications, but it is designed to allow you to go deeper and customize the various features and components as you need, all in a Spring idiomatic way. Now, in the demo, we used a pattern called RAG, that is Retrieval Augmentation Generation. RAG is used in scenarios when you want to integrate additional information such as business context or business data or anything else that you need that isn't pre-trained into the large language model. And this additional data is used to supplement the prompt or the input text. This is a vital technique for enhancing the model's understanding and consequently for the personalization of responses. The RAG pattern works broadly like this. When you receive an input or query, instead of directly composing a prompt and sending it to the large language model for an answer, what we do is we fetch contextual information from a retrieval-based model. Usually, this is an embedding model and stored in a vector database. And then we compose the prompt by combining the input from the customer and this contextual info to send to the large language model. In this way, we customize the response from the large language model so that it is more precise and more tailored to your business scenario. In the demo, we use this technique to supplement our knowledge of e-bikes and all of the e-bike accessories in our catalog to the large language model, so that when the user asks questions about our products that we are selling, the LLM is able to contextualize the response with all of the information that we have. If we did not do this, the only thing the LLM knows is any data that it was pre-trained on. So let's take a look at how this got implemented using Spring AI and RAG technology. This flow chart on the right, it shows all of the steps that the application takes. You can follow along with the source code, or you can take a look at the flow chart that we have. First, before starting the application, what we did was we pre-processed all of our business catalog data, all of our bicycles, all of the accessories, and we computed their embeddings to produce a JSON file that is loaded into a Spring AI class called Simple Vector Store. This is simply an abstraction over a vector database. Next, we loaded this vector store into the Spring AI class as an in-memory vector store. You can use external vector stores like 𝗦𝗲𝗀 or other whatever vector store you want to use, but in this demo, we just used an in-memory vector store. Once the application is running and we receive a query or a text from the customer, we get the embedding of the query from this external embedding service, and then we use this query with the in-memory vector store to get the nearest K data as information for the large language model. Finally, we compose a prompt message by combining this contextual information and the text that the customer sent from the store, and we sent this to OpenAI, and it responds with the answer. And we display this response on the web page for the customer to see. And so at a high level, this is how the flow works in response to a customer query from the web store. Next, we are going to take a look at Azure Spring Apps Enterprise. And we will look at how Azure Spring Apps helps you deploy and run and manage this AI app that you built. So if you are not familiar with Azure Spring Apps Enterprise, it is a fully managed service that helps you focus on your application code and not your infrastructure. It is a set of application lifecycle management features. It is built on Kubernetes that allows you to deploy, run, and manage your apps without requiring you to manage the underlying Kubernetes infrastructure. You can simply deploy your jars or point Azure Spring Apps to your repository, and Azure Spring Apps will automatically build, deploy, run, and manage your app. Not only this, Azure Spring Apps takes care of managing and optimizing the Kubernetes installation for you. You don't need to think about Kubernetes at all. Once deployed, you can easily monitor your application performance, you can fix errors, and you can rapidly improve your application. It is all integrated into the Azure ecosystem, and it works with all of your favorite Azure services. It is enterprise ready. Azure Spring Apps is jointly developed, operated, and supported by Microsoft and VMware. Azure Spring Apps is also as simple to use as it is powerful. You only need to do 3 things to get your application up and running on a world-class Kubernetes platform. First, you create an Azure Spring Apps instance with the first command. Second, you create an application within this service instance that you created. And third, you simply deploy the binaries that you built or the source code repository to Azure Spring Apps. Azure Spring Apps does all the hard work. All you need to do is point it in the right direction. One of the things that Azure Spring Apps helps you with is by automating software patching. We heard from many customers that they want to focus on their applications and the tasks that they need to do. Patching, keeping track of CVEs, understanding what needs to be patched and by when, this is something that distracts from the core of what you want to do. And so Azure Spring Apps helps you by patching everything that your application depends on, from the underlying Kubernetes clusters to CVEs in the JVM and to libraries that your application depends on. With auto patching, you can rest assured that your applications are always up to date and secure without the hassle of manual updates. Whether you're managing a single app or a complex enterprise environment, Azure Spring Apps simplifies the patching process and it streamlines your workflow. You take care of your application, we take care of everything else. On the left is a chart of when Azure Spring Apps auto patches and the frequency at which this happens. Typically, we will auto patch every 6 weeks, but you can set up planned maintenance windows by opening a support ticket, and we will hotfix deployed critical vulnerabilities during that time. We take care of the patching, and we make sure that your application is always running on secure libraries and a secure platform. And so in brief, there is something for everyone in Azure Spring Apps. If you are a developer, you can build and scale your workloads at cloud scale. You can easily apply cloud-friendly patterns such as configuration, service registration and discovery, automated patching, end-to-end discovery. You can get the full power of Kubernetes without having to deal with the knobs and the dials that Kubernetes gives you. You can create any number of environments with Azure Spring Apps Enterprise. You can have test environments and development environments, and you can advance them to production, and you can deploy this across the globe in all of the regions that Azure supports. If you're an IT operator, you can operate the service and environment at scale. This service becomes the home for distributed workloads, and you can connect these services with your favorite Azure monitoring services, log analytics, workspace, and so on. As you operate, you don't have to worry about middleware management. Azure Spring Apps takes care of all of the favorite Spring middleware that your developers enjoy. You get unlimited scale, and you can assign roles and responsibilities to match your teams as they are operating and deploying Azure Spring Apps Enterprise. You can use your favorite policy management that is standard with Azure, and you can monitor and automate end-to-end. Azure Spring Apps Enterprise fits in with all of your other Azure investments as you would expect. And finally, if you're an executive, Azure Spring Apps provides a very minimal total cost of ownership, high availability, and plenty of headroom to grow the workload. You can harden security with Azure Security, and Azure Spring Apps is fully supported by both Microsoft and VMware. And so I hope you can see how together Spring AI and Azure Spring Apps Enterprise will help you quickly adopt, leverage, and iterate on generative AI features in your existing Spring applications. You can easily integrate with Azure OpenAI, and with Azure Spring Apps, You just simply deploy your AI application and you don't have to worry about the infrastructure. Deploy and let Azure Spring Apps handle it all for you. The demo that we showed today is available on GitHub. You can follow this link to access the repository, and there is a README there that will help you deploy this application onto Azure Spring Apps Enterprise today. Thank you very much for your time.